Hi everyone. In this lecture, I'm going to talk about configuring change delivery. By the end of this lecture, you should be able to perform the procedure to create a classic replicate process, describe the self-describing trail files, start and stop a replicate process group, delete a replicate process group. In this lecture, I'm covering the last stage of configuring the Oracle Golden Gate. That is configuring the change delivery or the replicate process. As explained before, the replicate process reads the data out of the Golden Gate trail files and apply the changes on the target database using insert, update, or delete commands. You can apply data filtering on a replicate process. The filtering could be by a table, row, or even operation. The replicate process allows you to make some basic transformation on the data before you apply it on the target database. A replicate process can operate in one of three modes: non-integrated, integrated mode, or coordinated. Working in integrated mode is supported only in Oracle databases, whereas the non-integrated mode, and it's also called the classic mode, works with any database supported by Oracle Golden Gate. The replicate process that I'm explaining in this lecture is the classic replicate process. I will cover the integrated mode replicate and the coordinated replicate in separate lectures. Replicate process maintains its checkpoint information in a local file. Beside this checkpoint file, you have the option to create a checkpoint table in the target database. The replicate process keeps updating this table with its checkpoint information. It is highly recommended to create the checkpoint table because it is more efficient for the replicate recovery, and it helps you to recover after some specific failure scenarios. Although you can create the table in any schema within the database, it is advisable to create it in Golden Gate schema. You can specify the name of the checkpoint table in the globals file. In this case, all the replicate processes will use the same provided checkpoint table. You have the option to override this setting and provide a checkpoint table specific to a given replicate process. Checkpoint information written by the replicate includes the following: startup checkpoint. This is the first checkpoint made in the trail when the process started up. And current checkpoint. This is the position of the last record read by the replicate in the trail. When does the replicate write its current checkpoint into the checkpoint table and into the checkpoint file? A replicate writes its current checkpoint in two cases. Firstly, after it completes a transaction. It is guaranteed that a checkpoint is saved immediately after a transaction is committed. Secondly, at regular intervals. Every specific period of time, the replicate writes its current checkpoint. This means that the last checkpoint in the checkpoint file may not be the most recent transaction boundary. It could be the middle of a transaction not yet applied by replicate or an earlier transaction that was already applied. I will show you how to create a checkpoint table and assign it to a replicate soon in this lecture. Oracle Golden Gate Release 12.2 introduced a new format of the trail files. They are called self-describing trail files. This type of trail files has the definition of the source data structure embedded into the trail files. And in this case, you don't need to use source definitions file. Golden Gate saves two types of metadata in the trail files. One is called Database Definition Record, or DDR. As its name implies, this is information about the source database. The second type of information is Table Definition Records, or TDR. And this is the data definition of the tables included in your Golden Gate configuration. If you want to use the self-describing trail files, include the parameter use trail diffs in the globals parameter file. This parameter instructs all the processes to use the self-describing trail files. And this is the default behavior in Oracle Golden Gate 12.2. If you want Oracle Golden Gate to use the previous format of the trail files, use the parameter no use trail def in the globals parameter file. This is the default for backward compatibility. You use it if the Golden Gate of the extract process is of different version from the Golden Gate software used by the replicate process. The procedure to create a replicate process is as follows. Create a checkpoint table, although this is optional, but it is highly recommended. Edit the replicate parameter file. Add the replicate process and assign the check table to it. If the data definition on the source database is different from it in the target database, you must create the data definitions file in the source database systems and move it to the target database system if the version of the Oracle Golden Gate is older than 12.2. Finally, you start the replicate process. Let's see how you can implement this procedure. To create a checkpoint table, log in to the target database and issue the command add checkpoint table, followed by the table name. You can set any name you would like. As with all the Golden Gate processes, you use the command edit params or edit param to edit a replicate parameter file. I would show you in the incoming slides examples of the replicate parameter files. This is an example of a replicate parameter file when the data structure in the source database and the target database are identical, and when the trail files are of version 12.1 or older. First, you start with the keyword replicate, followed by the replicate group process name. Every replicate parameter file should start with this keyword. Then you need to provide the login information for the target database. Similar to the case of the extract parameter file, you will learn in a separate lecture how to hide the password in this file. The parameter assume target defs. When you include it in the parameter file, you are basically telling the replicate that the definitions of the tables in the source and the target are identical. The column names, the data types, the column size, and so on, replicate assumes that they are all the same in the source and the target database. Again, this is only needed in the Oracle Golden Gate of version older than 12.2. If this isn't the case in your project, if the source tables and the target tables are not identical, in this case, you should not use this parameter, and you must create and use a source definitions file. The next parameter is the discard file parameter. Discard file captures information about Oracle Golden Gate operations that failed. This information can help you resolve data-related errors. By default, a discard file is automatically generated whenever a process is started with the start command through GGSCI. This file will be saved in a subdirectory called dir rpt, and it has the extension DSC. However, For the discard file that gets generated automatically at startup, if a discard file exists, it is purged before new data is written. Therefore, you will lose the old error information. Obviously, this is something you want to avoid for a replicate process. For this reason, you need to override this default behavior, and that's why you are using the discard file parameter over here. With this parameter, you define the discard file name, use the append option, and sets its maximum size to 80 megabytes. When the append option is used, the process adds new content to the existing contents if the file already exists. After each file in this trail reaches approximately 80 megabytes, extract creates the next file in the sequence. Finally, we map the data from the source objects to their appropriate objects in the target database. This parameter has options to specify processing work such as filtering, conversion, and error handling that might be performed before the data is applied to the target objects. You will learn about those options in a separate lecture. The parameter accepts wildcard, where you can map multiple objects in the source database to multiple objects in the target database. The examples shown in the slide map the tables, employees, departments, and jobs in the source database to the tables UK employees, UK departments, and UK jobs in the target database without any filtering or conversions. This is an example of the replicate parameter file when the data source and the target source are not the same. Everything in this example is the same as the example in the previous slide, except that the parameter assume target diffs is replaced with the source diffs parameter. This parameter points at the source definitions file, which contains the metadata of the source data structure. As you know, if you are using Oracle Golden Gate Release 12.2 and you have configured the self-describing trail files, you don't need to generate source definitions file in the source database system. In this case, you simply don't have to use the assume target diffs parameter nor the source diffs parameter in the replicate process parameter file. Oracle Golden Gate will simply use the trail files to obtain information about the metadata of source data structure. If you use any of those parameters with Oracle Golden Gate Release 12.2 and the trail files were self-describing, Golden Gate will ignore those parameters and generate a warning message in the error log file. However, when you are using self-describing trail files, it is recommended to use the DDL parameter. This parameter is needed because when it is there, any DDL that has been issued in the source database and that has changed the source data structure, this DDL statement will be captured by the replicate, and therefore it will be aware about the changes that has been implemented on the source database. Of course, the same rule applies in the extract side. The extract parameter file must have the DDL parameter used as well, so that the DDL statements would be captured by the extract and written to the trail files. We have created the checkpoint table and created the parameter file. Now you create the replicate process. To do so, use the add replicate command. The first example of this command creates a replicate process named RHR2 and reads from the given trail files. This process will use the checkpoint table defined in the globals file. If there isn't any check table defined in that file, the replicate will operate without using any checkpoint table. The second example creates a replicate process with the same name and trail files, but it uses the checkpoint table that is specified in the command. If the data definition in the source database is different from it in the target database, and if the trail files are not self-describing, you must create a data definitions file. The procedure is easy. You start with creating a temporary parameter file. In that file, you specify the path and the file name of the definitions file, connect to the source database, and define the tables that you would like to map with the target database. After that, you use the defgen utility to create the definition file as shown in the example in the slide. The definitions file will be created and you copy it to the target database system. After creating the replicate process, you should start the replicate process. Although the command is very easy here, but we should stop a little bit over here. If no updates happened to the source from the time when you started the initial load process all the way up to this point, then you don't have any problem and you can start the replicate straight away. But if updates were going on during the initial load process, then you normally would have two scenarios. In the first scenario, you know the serial identifier of the last transaction executed by the initial load. We used this serial identifier in the initial load practice, and in Oracle database it is called SCN. If you know this number, you should tell the replicate when you started to apply the transactions that passed that number. In the second scenario, you don't know or you don't have the CSN number of the initial load step. You should always avoid reaching to such a scenario, but if you still find yourself dealing with such a case, then you do the following. Start the replicate process without specifying the CSN number. In this case, the replicate process will start applying the transactions from the beginning of the active trail file. Of course, as a result of that, the replicate may try inserting some rows that are already there or update some rows that aren't there in the target database. This is called collisions or conflicts in Oracle Golden Gate terms. I will show you in the next slide how to handle collisions in cases like this one. So you reach to a condition where you don't know from where the replicate process should start reading the trail file. And therefore, you let it start from the beginning of the trail file. In this case, the collisions will definitely take place, and you must tell the replicate how to handle them. For cases like this one, you can use the parameter handle collisions. When you add this parameter to the parameter file, you are telling the replicate to handle the collisions as follows. If the row that you want to insert is already there, then overwrite the existing one. If the row that you want to update is missing, then ignore the update operation. If everything goes fine, the collisions should eventually go away. And when this happens, stop the replicate, remove that parameter from the parameter file, and start the process again. To stop the replicate, you use the command stop replicate followed by the group name. To delete it, you need to first log into the target database, then use the delete command, as shown in the slide. In this lecture, you should have learned how to do the following. Perform the procedure to create a classic replicate process, describe the self-describing trail files, start and stop replicate process, and finally delete replicate process group. The next lecture is a practice lecture, and it is probably the most important practice in the course. You will learn how to configure change synchronization in Oracle Golden Gate. That is how to create extract process groups and replicate group. See you over there. Thank you very much.